Hi everyone, welcome to the channel. Today we will be continuing with lecture 3 for LEED Green Associate Exam for the chapter Energy and Atmosphere. So without any further delay, we will move on to our presentation. Well, in this chapter, there are total 4 prerequisites and 7 credits, and it holds a score of 33 in total. Now we have covered about 2 prerequisites and 2 credit to associated credit in this category. Today we will continue with another prerequisite and its connected credit. So the prerequisite is building level energy metering and the related credit is advanced energy metering with 1 point. Why I am relating this prerequisite and credit together? Because it will be more easy for you to understand the concept and the requirements are almost same. First, let's look on to the prerequisite building level energy metering. The intent of this prerequisite is to support energy management and identify opportunities for additional energy saving by tracking building level energy use. Requirements including install new or use existing building level energy meters or submeters that can be aggregated to provide building level data representing total building energy consumption, and it can include electricity, natural gas, chilled water, steam, fuel, oil, propane, biomass, etc. And also the project should commit to sharing with the USGBC the resulting energy consumption data and electrical demand data if it is metered for a 5-year period, and it should be from the beginning on the date the project accepts LEED certification, or it can be the typical occupancy date, whichever comes first. And also at a minimum, energy consumption must be tracked at 1 month interval. Now let's discuss the related credit for the prerequisite building level energy metering, that is advanced energy metering, and it can get 1 point. The intent of this credit is to support energy management and identify opportunities for additional energy savings by tracking building level and system level energy use. In order to achieve this credit, we need to install advanced energy metering for the following. 1. All building energy sources used by the building, and another is any individual energy and uses that represent 10% or more of the total annual consumption of the building. And also the meters must be permanently installed and record at intervals of 1 hour or less. And also it should transmit the data to a remote location. Let's discuss the final prerequisite in this category and its associated credit. So the prerequisite is fundamental refrigerant management, and the credit is enhanced refrigerant management with 1 point. So the prerequisite is fundamental refrigerant management, and the intent is to reduce the stratospheric ozone depletion. You can see where the ozone layer is located. It lies approximately 15 to 40 kilometers, that is around 10 to 25 miles above the Earth's surface in the stratosphere. Now let's talk about the requirements. Number 1, do not use CFC, that is chlorofluorocarbon based refrigerant, in new heating, ventilating, air conditioning and refrigeration, that is HVAC and AL system. When reusing existing HVAC and AL equipment, complete a comprehensive chlorofluorocarbon phase out conversion before the project completion. And finally, existing small HVAC and AL units and other equipment such as standard refrigerators, small water coolers, or any other equipment that contain less than 0.5 pounds, that is 20 to 25 grams of refrigerant, are exempt. While we're discussing about ozone layer depletion, we need to know about Montreal Protocol. Montreal Protocol signed in 1987 and is a landmark international treaty aimed at protecting the stratospheric ozone layer by phasing out the production and consumption of ozone depleting substances such as chlorofluorocarbons. Before the Montreal Protocol, there were no global restriction on the use of these substances, which led to the significant damage to the ozone layer. This protocol has been highly successful, leading to a substantial reduction in the production and use of ozone depleting substances. The result you can see on the right side graph. As a result, the usage of CFC has dramatically decreased. However, hydrofluorocarbons, abbreviated as HFCs, which do not deplete the ozone layer as of this CFC but are potent greenhouse gases, has seen increased use as the substitute for CFCs and other ozone depleting substances. Efforts are now underway to manage HFCs under the Kigali Amendment to the Montreal Protocol, which was adopted in 2016. This aims to phase down the use of HFCs due to their high global warming potential. The related credit is enhanced refrigerant management, and it can get 1 point. The intent is to reduce ozone depletion and support early compliance with the Montreal Protocol while minimizing the direct contribution to climate change. There are two options for achieving this credit. Option 1 is non-refrigerant or low-impact refrigerants. Do not use refrigerants or use only refrigerants that are naturally occurring or synthetic that have an ozone depleting potential of 0 and a global warming potential of less than 50. Option 2 for this credit is calculation of refrigerant impact. So to achieve this requirement, we need to select the refrigerant that are used in HVAC and our equipment to minimize or eliminate the emission of compounds that contribute to ozone depletion and climate change. The combination of all new and existing base building and tenant HVAC and our equipment that serve the project must comply with the following formula. For your LEED Green Associate exam, the calculation part won't come, you just need to know the concept well. Well, that's the end of today's lecture. Tomorrow we will continue with the remaining credits for this chapter. Yeah, so till then, bye. And if you like the content, please support my channel by subscribing to the channel. So that's all. Thank you.